Through this video, all of you will be able to first, learn how flipped classroom is applied in daily life. Second, establish and perform one-way Anova. Third, identify the data from Anova table. And lastly, calculate all the relevant statistics and analyze the finding from the Anova table. The definition of Anova is a procedure that is used to test the null hypothesis that the means of three or more populations are all equal. The Anova, short for analysis of variance, provides such a procedure. It is used to compare three or more population means in a single test. The analysis procedure also can be used to compare two population means. However, the procedure learned in hypothesis testing are more efficient for performing tests of hypotheses about the difference between two population means. That's why Anova are used to compare three or more population means. For more knowledge, Anova was created by British statistician Sir Ronald Elmer Fisher in 1918. The most common types of Anovas are the one-way Anova and two-way Anova. By using a one-way Anova test, we analyze only one factor or variable. For instance, teachers at a school who have devised three different methods to teach arithmetic, they will test for the equality of mean arithmetic scores of students taught by each of these three different methods. We are considering only one factor, which is the effect of different teaching methods on the scores of students. On the other hand, for two-way Anova, we use it to determine how two factors affect response variables or variables. For example, if different teachers teach arithmetic using these three methods, we can analyze the effect of teachers and teaching method on the scores of students. However, in today's lesson, we will focus on one-way Anova. Now, we're going to explore how Anova, a statistical method for comparing means, can provide valuable insight and help us make informed decisions in our daily life. As I mentioned before, we will use Anova in education sector to help teachers analyze the most effective teaching method for enhancing students' comprehension. Other than that, the Anova test can also be used in the business world. If a company wants to test the effectiveness of 5 or more different marketing strategies, they will use Anova test. The company will randomly select a sample of customers and divide them into 5 groups. The group will be given different marketing strategies to see which one is most effective. The company will then analyze the data to see which marketing strategy had the most positive effect on the customer. Next, in the sport industry, Anova is used to analyze data from athletes in order to improve their performance. This data can be used to identify areas where athletes need to improve and design training programs that will help them improve in those areas. Anova can also be used to compare the performance of different athletes and identify trends in performance over time.
Next, we must know the concept of the Anova and the keyword. First, correction factor. So how did we calculate correction factor? Summation of variable y power of 2 divided by total number of population. Next, SST. The formula is total of all observation in the sample in the I treatment power of 2 minus correction factor. Next, SST. The formula is total of all observation in the sample in the I treatment power of 2 minus correction factor divided by n. Next, SSE. The formula is SS. Next, MS3. The formula is SS3 divided by k minus 1, where k is the total number of population. Next, MSE. The formula is SSE divided by n minus k, where n is total number of observations. Next is F test. The formula is MS3 divided by MSE. Next, if the significant level alpha is given, this property allows us to make statistical hypothesis testing whether to accept the statement mu1 equals to mu2 and so on. In this statistical study, the statement is formally written in the form H-null, where all three population means are equal. If the null hypothesis H is rejected, this leads us to accept the alternative hypothesis H, written in the form not all population means are equal, or at least two means are unequal. Next, we move to hypothesis testing. There are 5 steps. Firstly, we need to setting up the hypothesis that include H null and H alternative. Secondly, we need to state the test statistic by using formula F test. Thirdly, we need to use alpha equal to something depends on the question to find the critical region. Then we need to find F alpha, K minus 1, and minus K. Next, we need to do computation by constructing Anova table. Lastly, we need to make decision and conclusion which determine whether we must reject or fail to reject H null based on the F alpha and F test value.
So now I will show you how to create an Anova table. First and foremost, for the first row, it has the source of variation, sum of degree, degree of freedom, mean square, and lastly value of test statistic. Under the source of variation, we have a treatment which is between the levels, error within the levels, and also the total. So now let's take a look at the first source of variation, which is treatment. To find the sum of degree, we will use SS3 and each degree of freedom is K minus 1, while the mean square for treatment is MS3. Next, the second source of variation is the error. To find the sum of degree, we will use SSD and the degree of freedom for the error is N minus K. MSD will be used to find the mean square of the error. Besides, the last source of variation we have is total. So basically, to find the sum of degrees, we use SSD and each degree of freedom is N minus 1. If you are not sure if your SSD true or not, you can sum up SS3 and SSD to get the total. Lastly, for our table, we have value of test statistic, which is F test. The formula for F test is MS3 divided by MSD. Okay, now let's take a look at the requirement of Anova. First, they are given a sample from the K populations. Next, the population has the same variance and the populations are normally distributed. And lastly, the K samples are independent of each other.
Hey, Assalamualaikum. Good morning, class.
Good morning, teacher.
How was your day?
Nice.
So basically, last week, teacher gave you a YouTube link, right?
Yes.
Have you watched it?
Yes.
In that video, we learned about analysis of variance, which is Anova. In Anova, we learned how to compare 3 or more means, population, or group. In Anova also, we learned about source and key term. For source, we have treatment and error. For the key terms, we have correction factor, CF, degree of freedom, sum of square, and mean square. Cheryl, how many sum of square we need to have in Anova?
2, which are SS3 and SSE.
Good job. SS3 is for treatment and SSE is for error. For mean square, we have MS3 and MSE. MS3 is for treatment, MSE is for error. In Anova also, we need to testing the hypothesis. We should testing using F test, which is student can refer to table 9 from the textbook. Also, F test, we use F alpha, K minus 1 and N minus K. K minus 1 and N minus K, we get from degree of freedom. For F computation, we can get from divide MS strip with MSE for F computation. So for the overall YouTube video, do you understand?
Yes.
So if you understand, I will give you one example from our final exam.
Today I'm going to show you an example for Anova question. Question 1. A study was conducted to determine the factor that reduces blood pressure the most, medication, exercise, or diet. 15 patients at a hospital with comparable levels of high blood pressure are randomly assigned to each treatment group. After 8 weeks, the drops in systolic blood pressure for each patient was measured as shown below. So we have 3 treatments which are medication, exercise, and diet for 15 patients. Thus, we know our K was 3 and our N was 15. Question A. Use the data above. Construct an ANOVA table to test the claim that all 3 of the treatment produce the same drop in blood pressure at 5% significant level. So we know our K was 3, our N was 15, and our alpha, which is significant level, was 0.05. To answer this question, there are 2 methods, which is calculate manually or using scientific calculator. If students want to calculate manually, they should know the formula for each key term. The key term was correction factor, sum of square total, sum of square treatment that has been discussed from Irzati before. If students want to calculate using scientific calculator, first they need to reset the calculator. Go to shift and press 9 for reset, choose 3 to initialize all, press equal and AC. By using calculator, we don't need to calculate correction factor. Thus, we go direct to sum of square error. To calculate sum of square error, the flow are go to menu, choose seek for statistic, 1 for 1 variable, and we need to insert the value column by column. So we insert the value of medication first. 11, 10, 8, 14, and 13. After that, press AC and go to OPTN, which is option menu. Go below and choose 2, which is variable. Because of ANOVA, we want to compare the variability of population. So we take 2, which is variance, and we multiply with 5, which is the row of the column, which means our N is 5. After that, after get the value, we must store the value into one variable, for example, A, B, or C. So we store the value into A. After that, repeat the same step for another 2 columns for exercise and diet. After we store the value into the variable A, B, and C, to find the sum of square error, we need to sum up the variable, all the variables. So we press alpha A plus alpha B plus alpha C. And then we got 82.4 for sum of square error. To calculate sum of square total, students have to insert the whole data and our N, which is 15 for the population. So we got 184.9333. To calculate sum of square treatment, we have to minus sum of square total with sum of square error. So we got 102.5333. As we know, mean square of treatment, the formula is SS3 over K minus 1. So our SS3 is 102.5333 over our K is 3 minus 1. So we got 51.2665. To calculate mean square of error, we know the formula was SSE over n minus K. Our SSE, which is 82.4 over 15 minus 3. So we got 6.8667. Now, to test the claim that all 3 of the treatment produce the same drop in blood pressure at 5% significant level, So the claim was all treatment produce the same drop in blood pressure. To do the hypothesis testing, we know that our H null, mean population 1 equal to mean population 2 equal to mean population 3. Thus, our H null, at least one of the mean population 1, mean population 2 are not equal. To calculate the F computation, we must do the Anova table and got the test statistic value. To compute the F test, we know the formula was MS street over MSE. So our MS street 51.2665 over 6.8667. So we got our F test computation 7.4659. To find the value of F test, we are using table 9, percentage points of the F distribution. So we know F, our alpha 0.05, K minus 1, 2, N minus K, 12. Look at the table 9, K minus 1, 2, N minus K, 12. So we got 3.89. For the last step, we want to conclude that since 7.4659, which is F computation, is bigger than 3.89, which is F test from the table, so we reject the H null at 0.05 significant level that at least one of the treatment produced unequal drop in blood pressure. Thus, the claim is false. So we reject our H null and accept H1. That's all from me.
Okay, next we will play a quizzes. There are some questions related to Anova. You guys will work as one group. So now you have 3 members, right? You have to discuss and choose the correct answer in this quizzes. Okay, I will start now. Okay, question 1. How to find degree of freedom treatment? Are you sure?
Yes.
Good job. Next question. Find the correct formula of TS. F test.
3. MS street over SS3.
This is F test for computation, right?
Yes.
Are you sure?
Yes.
Okay, let's see. Alright. Second last question. Requirements of Anova Excel. We have 4 requirements.
3.
Third one.
Third one.
Depends.
To be independent.
Yes.
Good job. Last question. H-null. How about H1?
H1.
At least two.
At least two of the ways are equal.
So H-null is equal. Question 1 is K minus 1. Question 2, F test, MS street divide by with MSE. Question 3, MS street divide K minus 1, which is MS street. Requirements of ANOVA. K sample need to dependent of each other. So the second one is wrong. 5, H null is mean 1, mean 2 is equal.
Yes.
So we see that you understand in this topic. After this, I will give you one tutorial and you need to answer. Next class, we have to discuss together.
Okay.
So you need to do the homework, and I see you on next class.
Okay, thank you.
Thank you, class.
From previous scene, 5 students were selected randomly to undergo a test. So, the teacher using Anova to determine the most effective method. There are 3 methods that have been chosen, which are flipped classroom, online classes, and traditional classroom.
Since test equals 31.3442 is more than the critical value of f equals 6.93. Hence, we reject the null hypothesis and conclude that the means of the 3 population are unequal. In the other words, the 3 different methods of teaching seem to affect the mean scores of students.
Overall, this guide covered everything you need to know about Anova, including its types, computations, and how to build Anova table. Therefore, as you can see, Anova is a powerful statistical technique used to compare the means of 2 or more groups. It helps to determine whether there is a significant difference between the groups, and is also used in various fields such as engineering, science, medicine, and also social science. However, it does have drawbacks, which are assumptions. Anova assumes that the data follows a normal distribution and the variance is equal across the group. Thus, violation of these assumptions can lead to inaccurate results. That's all from us. Thank you.